Hi all. So it's kind of a tradition that I get the post-lunch slot. It's the second time this year I'm getting this slot. So I hope you all ate well, but I hope that you're motivated a bit. And I thought that I will do some game where I say hack and you say fast, but are you in for it? No. Okay, so let's start with the talk. I'm here today to speak about vaccination and anti-honeypot approach. It's not that I'm against honeypots. I'll clarify that a bit later on. I'm pro a different approach of repelling attackers by acting the other way around from honeypots. Wonderful animation. You'll see a lot of those animations during my talk. Be ready for it. What I'm trying to do is, well, today we are in a world of like we are like trying to chase malware. It's just like cat and mouse game, but well, we end up most of the time the other way around, where you know the mouse chases the cat, and yeah, it's quite problematic. And I feel that we are too much in this state, and rather the other way around. So what I'm trying to do is to turn it around. Well, it's also my first time in Canada. Yeah, yeah. I want to speak a bit about it before I start with all the technical, like boring stuff. When I flew here, I thought that that's what I'm about to see. Um, yeah, this was my like my idea of Canada, like till now. Oh, I then remember that there's also this guy. I'm not sure he looks like he's Canadian, but Mountie, Mountie, yeah, Mountie. Um, I'm not sure he's Canadian, but it was also my idea of Canada. But then I remembered that there's also like this guy, which is one of my favorite singers, songwriters, and he's also Canadian. So kudos for you, Canada. And I thought, no, Neil Young is not the only one. So yeah, there are plenty of more amazing people from Canada, which I really like and appreciate. And what? Oh, yeah, but there's this guy also. So yeah, so Canada, this is on you. Yeah, this is the last the lousy animation of my intro to Canada. So what's next? What we are about to talk today here, um, a bit about honeypots. What is a honeypot? A bit of like basic concepts about honeypots. Um, what is an anti-honeypot, but not in the world of computer security, but in the nature. It's not my idea. There are a lot of cases in the nature of anti-honeypot. And from there, we'll take this concept and apply it to computer security with hands-on examples and really deep technical stuff, which I hope you're up to. Um, we'll do a bit of good idea, bad idea when applying vaccination to real life enterprises or even home users. And we'll also have a live demo. Okay, so a bit about myself. Hi, I'm Gal, which is wave in Hebrew. I'm a 21-year-old geek from Tel Aviv. My company is not mine. I'm working for it. It's called Minerva Labs. This kind of my day job, what you're seeing here today. But this is not like a commercial promotional talk. So if you want to talk about later, it's okay. If not, it's okay also. I'm calling myself malware psychologist because what I'm focusing on is the fears of malware, what it tries to evade. Um, I invented the term. It's not like an evangelist like all of those guys. I'm not a. I'm just a malware psychologist, a senior one. I know my way around all kind of weird exotic languages like Python and Java, and I know like a bit more useful ones like Arabic also. Um, are there Arabic speakers in the crowd? أهلا وسهلا فيكم بمناسبة هاك فيست 2017. So yeah, and also I've learned another nice linguistic joke, which I thought I'll do here today. Um, as JFK did, and it's like visiting Berlin. He said, ich bin eine Berliner, right? So, ich bin eine Quebecois. right? Quebecois is the term. Yeah, so another nice linguistic thing. Um, I did tons of stuff from PowerShell, little scripts to attacking SCADA systems. It's all important, but what I like about this talk, all of the different stuff I did, they all have some kind of a common ground. They all try to evade some points, and this allows us to vaccinate against it. You'll see it later on in stock. It will be much more clear. So if you want to follow me or ask me questions, this is my Twitter, by the way. If you need to take any photos during the talk, feel free. I don't mind. It's a bit too fast sometimes. There are a lot of links during the talk. Um, feel free to do so. Okay, so let's start with what is a honeypot. We'll do it James Bond style. You can see on the right side, it's Sean Connery, and on the left side, it's Xenia Unatop from the classic GoldenEye. So she's the honeypot. It's a bit sexistic, and James Bond is known to be some kind of a misogynistic scumbag, but, well, she's the honeypot. She abuses James like his, like, I don't know, hunger for a beautiful, dangerous woman, and she's always the first girl to appear in a Bond movie. She's doing like this little dance, and she looks like a catch for James. And then he comes over, but then most of the time he realizes, oh, you're not what I thought you are. So, bang, and no more Xenia Unatop. And that's like what happens in most of Bond's movies and in life. Most of the times there are good products which do honeypot related kind of stuff, but this happens quite a lot. So this is a honeypot. What is an anti-honeypot? Well, I like to think about anti-honeypot as a very natural approach of repelling attackers. You can see um, those two snakes here. And this photo, it's quite easy to differentiate one from another. One is the milk snake, and one is the coral snake. One is venomous, and the other is not. Um, the one which is not, which I think is the milk snake, he tries to mimic the one which is venomous, and by that he repels the kind of, I don't know, birds or whatever that tries to attack it by just looking like the one which is dangerous. That's the kind of stuff we are going to do today in order to repel attackers from our computer. We will look like we are venomous, poisonous, and we'll do our best. And by that, we will repel real life threats, and a lot of them actually. There's another example of two butterflies. It's called, by the way, Bayesian mimicry. I think so. This kind of butterflies, it was recently announced that it is not this. It's like a really biological thing, but it's not the exact kind of mimicry. But also, those butterflies are, at least like a year ago, they were considered to be hackers. You have the monarch butterfly and the viceroy butterfly. You can see that they look a bit different. And it was considered that one of them tries to mimic the other, which turned out to be false, but who cares? And by that, some birds just like avoided eating it because it will, I don't know, cause them like diarrhea or something. I don't know. So yeah, they're also hackers. They don't type color 0A3, but they're also kind of hackers. Okay, let's take this talk to a bit more practical place because, yeah, vaccination is an amazing concept. Yeah, it's working, but it's working in the nature, and we are not going to take our PC from back home and paint it like it was a venomous snake, or I don't know, paint like the butterfly wings on it. It it most definitely won't work. And first, in order to repel the attackers, we need to know what they are afraid of. And I did this work of categorizing their fears. I started about a couple of years ago, and recently I found a new fear of malware. So this is like a 4++ ways to repel bad guys. Let's start with the first fear. You guys in the crowd, how many of you are blue teamers? At least, yeah. So more than one. Um, they're afraid of you, and they're afraid of analysts. They're afraid of anyone who tries to dissect them. They're afraid of running in sandbox. They're not actually afraid. They just think it's more cost effective not to be executed in a sandbox, because then they'll be captured and analyzed, and all of their expensive array of VPNs and VPS and God knows what, which they really tried hard to set up, it will be wasted and it's expensive. And if you're a cybercrime gang, well, you want to be cost efficient because you have competition. It's like a really competitive market, I think. So they're afraid of first, like virtualized and analysis environments. Sometimes they try to mislead a reverser directly if you manually analyze them. Sometimes they want to full like automated analysis tools like Sandbox. They seek hints for either static and dynamic analysis tools like IDA Pro, or Wireshark, which is dynamic. It's a sniffer now, but debuggers, and they seek for the actual infrastructure for VirtualBox, for VMware, for QEMU, and all this kind of stuff. It's been out there for years now. This little snippet, it's a very simple evasion technique. It's like finding a window of Ollie debugger or of WinDBG, and it's been out there since Black Hat 2007. It's over 10 years old. So it's not a kind of a cutting edge technique. You don't need to. You can evade this way from a lot of like automated analysis and manual analysis. Although this kind of stuff, I find it a bit like insulting, because I know that when I debug malware, I look exactly for this kind of stuff. And well, dude, you must be kidding me if you're doing this kind of stuff. I'm debugging you using a debugger, so I can see you're doing this kind of stuff. But that's my personal idea about it. So another example from this is a Loki sample from a bit more than a year ago. Are there any ASCII ninjas in the crowd? Well, if you look up close, you'll see that there's like a really complex jumping array over here, and it's just like if it matches like car by car string, which it gets through get username A, it will terminate, but only if all of the letters are found. And if you translated this thing down here from ASCII to human readable stuff, it will be sandbox. So this Loki sample will never run on your machine if your username is sandbox. I actually considered changing my username back home and then at my grandma's PC to sandbox to avoid this kind of stuff. It will work. If you know about like the recent Emotet, which wreaked havoc, look up close at its source. I don't know if it's source, like I think that Joe Sandbox has a really good decompilation of its source code, and it is afraid of exactly the same thing. Just FYI. So, yeah, a bit more recent example. You all know WannaCry, but have you heard about UIWIX? No. There was a bit of talk about it. WannaCry, you could have got the sample of it. You just needed to set up an SMB honeypot, but UIWIX, on the other hand, it was a bit more smart. So researchers had really tough time finding a sample of it. And why? It's just like copy-pasted code from repositories. It's this like it's did the easy debugger present. It searched for pipes. It searched for loaded modules and for other loaded for files. The most elementary stuff you can think about. I actually was able to find the source where it copy pasted from. This like almost the exactly same order of the DLLs, and this also is almost the same order. Um, it's amazing to see how easy it is to be stealthier, like almost totally completely stealth, because it was never observed almost in the wild, and they did have an operation. So I guess that they were able to infect guys. They used eternal blue and double pulsar. So like everyone else, they must have some kind of success. This one is a bit even more extreme. You can see that the exact same pattern you see here, by the way, with way too much backslashes. Somehow Windows behind the scenes handles it, but you can see the exact same order over here and over here. And funny enough, where this arrow points, you can see that both of those also copy from each other because they all also have this closing bracket thingy over there. And well, I don't know who copied from who, but also another copy-paste job. All of those artifacts relate to virtualization infrastructure, like Cuckoo. I think Cuckoo was on the previous slide. And here it's just like either a VMware or VirtualBox. Again, nothing new. It's all known. It's a copy-paste job. I have actually another talk about writing malware from scratch using copy-paste, but this one for maybe next year. Well, next fear. They're also afraid of like blue teamers, but the other way around. Today, you have great security products. Some of them are more expensive than others, some are less expensive, some of them are for free, but bad guys can test their stuff offline. They can learn you. Let's say a bank buys your, I know, let's say a ESET, whatever product, and it's a very large bank. So ESET will have the logo of this bank in their website. Oh, I know, Bank of America is using our product. And well, bad guys can, I have nothing with ESET, by the way, they're actually a good product. But then bad guys can test offline how we're doing against them. Are we good? Are we not? And they can decide based on the results of their execution in their lab against these products. Well, should we afraid of them? Shouldn't we? Um, yeah, in most cases, they won't beat all the products, but we had a case of Tesla Crypt and Locky, a different variant of Locky from roughly a couple of years ago, where they executed in all cases, other than if there was a registry key associated with ESET, Kaspersky Lab, or not GData, it was Avast. I have the sample here for the live demo later on. I'll show it to you live. Well, they know that they bypass like 90% of the AVs, and they have their operation ready to go, and it's expensive to, don't press the button, but then you have a very costly infrastructure set up. So, and as we said, you need to be cost effective. So, well, we can be afraid of only 2 vendors and still be very effective. So why not? Let's just see if those registry values are present, and by that we'll decide if we execute or not. And some examples for similar one, similar malware which did it, it's NotPetya, by the way. I'm not going to speak about the affiliation of NotPetya or BadRabbit, but NotPetya actually checked if there are specific processes related to Norton, Symantec, which is same, and Kaspersky. It was a bit complex. They did a really nice trick using a byte mask. And, the bottom line is that they had like 5 different capabilities. And if you had Kaspersky, specific ones won't be executed. If you had Norton and Symantec, other ones won't be executed. I did all of the bit calculation over there in a table. And if you had either Kaspersky or Norton/Symantec, you had a really good chance that it won't decrypt either your MBR or will propagate through your network, which is amazing. It's just like by having specific AV, which doesn't prevent anything, the malware will decide not to attack you. And well, this prevents like 20% of the stuff, but later on we'll see how we can create this kind of indicators that will make the malware be afraid and to prevent even 40% of the capability of the malware. It's not like amazing, but think about it, most of the damage won't be done. Bad Rabbit, just the same. Again, nothing about affiliation or I'm not trying to, yeah, it's the Russians and North Koreans that God knows who, but it's exactly the same trick. They calculated some kind of a custom hash and compared it. And they did all of the same byte calculations. Kaspersky released I think it was Kaspersky, yes, from SecureList. They released all of the processes. It's either Dr. Webb or McAfee in this case. And actually, I did a test in my lab, and it will keep executing no matter what, but it won't encrypt the disk locally. The MBR will still be destroyed, so it's not that helpful in this case, but you can create all of those processes, and maybe the next not bad rabbit, Petya something will be prevented by just like vaccinating your machine with random processes. And by the way, I released, I rewrote the hashing that was used by Bad Rabbit in Python. I did a little experiment brute forcing it, but Kaspersky released the results before me. So if you want to see it, it's available in my GitHub account under Good Rabbit. Yeah, another joke. Okay. Next sphere, the first image of a cat in the slideshow, by the way. We had like cartoons back in the first slide, but no matter. Bad guys are also afraid from themselves. Just like the classic vaccination, it's a subclass of vaccination actually. They create infection markers to avoid infecting the same machine twice, because God knows what happens if you encrypt like with two multi-threaded ransomware the same machine twice. Like, what is the first private key? What was the first like private and public, and then the AES, and you don't know what was encrypted when, and it's like awful thing. So you use infection marker, and if you start to infect a machine, you won't do it again because you don't want to make like the encryption irreversible, or you don't want to execute two instances of Trojan horses because maybe if you are binding a TCP port, you'll get an error because you can't bind the same TCP port twice to the same address because, physics. They sometimes do it properly. They sometimes do it less than properly. They can, for example, hold the TCP port as a mutex, but they most of the times use an actually proper mutex. There are so many examples for it. This one is from Configure, which is just the same as more examples you see later in like the next couple of slides. And the pattern I always seek as a reverse engineer is get last error and then compare it with B7, which is already exists, whatever. This means that the mutex already exists, and then you can see the exit process called like a couple of lines later. This one's pretty small, so just trust me. But always seek for this pattern. Another one, which is a bit more contemporary. This is yet another Loki example from a very early Loki. This one is from a guy named Sylvian. I can't pronounce his last name. Sorry, guys. It's like amazing what he did here. What like the bad guys did here. They created a registry key called completed with a value which was either true or false. It was under HKLM software Loki. They actually did amazing software engineering here. I would have done exactly the same if I had like a commercial product called Loki, I guess. And if you created the same value under the same key in advance and the completed was set to true, it won't encrypt your machine because it is already encrypted. Well, the registry value says that true, so yeah, it's already encrypted. So, and if I create in advance, I know that there's like a large Loki outbreak. And I vaccinate endpoints against this outbreak by creating this registry key. I'm winning the game, no matter which packer you use, which obfuscation, infection vector. The payload is the same payload, and it's going to check this registry value under the same registry key, and I can prevent it from running this way. So, yeah, there are a bit more like recent examples like Spora. Spora with this Hoffler text font wasn't found thing. It also did the same thing. It searched actually a mutex which was M concatenated with the volume serial number in a decimal format. We released like our guys back home released a vaccination against it. If you want, you can use it. I think Spora is no longer a thing now, but it's nice to have it publicly. It's of course open source, etc. WannaCry, again, one of the largest infections. Yeah, we had this nice little guy, malware tech blog, which is currently under, I think, like criminal investigation or something. He found a kill switch, which wasn't vaccination, it was a kill switch, but there was also vaccination. You had a mutex, which with the same pattern, you can, I think this one is larger, so you can see it checks for this MS zone win, whatever, with an A concatenated in the end, which is not a real mutex, which you might see. And then you can see like the get less error, and compare EAX with B7, which is what I said you should always look for. And if you created this mutex, WannaCry won't run your machine. Also, in this case, we released a nice vaccination. This is a very interesting case because, when you double-click on a sample, Windows has this lovely concept of sessions, and it will run in your session. But WannaCry was spread over an exploit, and it was running in system privileges. So if you create a script and you vaccinate your machine by double-clicking it or, spreading it over WMI or something, it won't be executed in the same session as WannaCry. So yeah, you can even like take the sample, download it to your machine, double-click the sample after you double-click on the script, of course, and you can see, oh, it is prevented. I'm vaccinated. But no, you're not, because it's not running in the correct session. And we have a little like session about it in the last part of this slide, of this presentation. But you should be careful when you do vaccination. It's not like that simple always. Yeah. And yeah, also NotPetya and Bad Rabbit. We have this great dude, Amit Serpa, which is a friend. We found all the vaccinations for those. It's a simple file you need to create, and then you can get rid of those. I think it's not even an infection marker in Bad Rabbit's case. It's just like he prevents the capability to make it persistent. And by that, he just like, it's just like making the node crash in some way. And well, we have so many cases like this. I believe it's to be continued, at least like this genre of infection markers. We have it like since forever, since the early 90s. So I think we'll see much more of those. Next category of fears. Russian. Yeah, it's not actually like just specifically Russian, but we need to be careful with what we wish for when you do vaccination, when you create all kinds of markers. And, many ransomware won't infect you if you have Russian or Ukrainian or any kind of Cyrillic keyboard. Well, it's nice. So let's all add keyboards, Maybe they're afraid of, maybe they think that this nice little fellow will be after them. I don't know if they infect Russian citizens, possibly. He's like really cute and furry. I don't know why. But other software are what I like to call comrade targeted malware. That's my red alert voice. And they will infect you only if you have Russian keyboard. So Well, I'm repelling some of the attackers, but I'm luring some other attackers. So what my it's a bit of a tricky game. As I said, vaccination is nice. It can be really good, but we should be careful with what we wish for. And yeah, that's like my last all new category of malware fears, crypto miners. Crypto miners everywhere. It's like my first attempt to use this meme, and I think it is right. And crypto miners is the next ransomware. This from like where I'm standing and from my point of view, it's a quick, easy money, which is hard to detect. Ransomware are well, it's difficult today to write a proper ransomware. Um, there are a lot of like I don't know if it's like necessarily consumer grade software that handles ransomware today, but to do like a proper ransomware which will attack a properly defended organization, it's pretty difficult today. And crypto miners are much more efficient by being lucrative with little knowledge, and I think it is we're going to see much more of those. But with this new malware, we see new type of fears. And crypto miners are, interestingly, afraid of Task Manager. Yeah, your friendly neighborhood Task Manager. Because when you enter a website which uses a coin hive or somebody infected you with a variant, like a modified version of the XMR IG, XMR rig, or God knows how you call it, it will grind your CPU many times. The first time I browsed to a website which hosted the CoinHive script, I heard a malware for the first time in my life. My CPU went crazy. And I have an i7, so it's not like a weak CPU or something. And the first thing I did was opening Task Manager, understand what the hell is happening. Maybe it's again, I don't know, my AV. But no, it was the browser. So yeah, Chrome is lousy and grinds your CPU from time to time, but it's not that crazy. And I then eliminated tab by tab, and I understood that a large website is using CoinHive. And I had this what the fuck moment, but this malware evades this kind of detection by analysts like me by just searching for the window of either Task Manager or you have some Russian things there, which is Task Manager in Russian. And whenever a window like this is opened, it will just terminate, which is nice. There's also like another thing called Anvir. Anvir is also a Russian task manager of some sort. This was taken from a campaign we unveiled a couple of weeks ago called the Water Miner. I don't know if you've heard about it or not. It was spread as a GTA mod in Russia. So this is why they target specifically Task Manager in Russia. This is one variant which searched a window. This one actually searched for Task Manager and Anvir exe as like the process names. They called the create tool help 32 snapshot the API, and then they just iterated over it. And if they found this process are running, they just terminated immediately because I don't want him to detect me. I want to stay on his machine. I want to make some more money. It just makes perfect sense, I guess. Well, yeah, so we know what are the fears. Well, we know already what is a honeypot, what is a anti-honeypot. We know how to apply the fears in the nature to fears in the infosec, like kind of a genre. But how bad guys know when to bug out? They don't look in our machine and say, oh, you are virtual, you are sandbox, you are there over there, you are trying to monitor me. No, they have specific artifacts. And I did kind of a categorization in this matter as well between static Windows artifacts like registry keys and values, files, folders, all can be created persistently. And this is what makes them unique. I can execute a simple script and just create all of those for good, and I'm okay. I can create, HKLM software, VMware Inc., and it's there for good. On the other hand, we have dynamic Windows artifacts, which are a bit more tricky. Processors, Mutex, Windows, like not Windows, the OS, Windows, the window you have in the OS. Um, it's like a totally different world because, we can, if we create files, yeah, you can create a file and forget about it. But should we try to run 10,000 like Windows processes, Mutexes, or whatever? It will, I don't think it will end good. I have a script for it too. We will try those scripts later in the live demo. They're also available online and same like under Galbit. I'll post the link is like in the next slide, so you'll be able to try it as well if you want to. But it's a bit more tricky to do this dynamic vaccination, you might say. There are more clever solutions, but they're like a bit more commercial, and I don't know about any product which performs this kind of a dynamic vaccination in large scales effectively, which is not commercial. A third category, which is very interesting, but I'm not doing it. It's not like a simple Python script to write in order to vaccinate, like using this kind of stuff. Well, you have low-level tricks, memory, abusing opcodes. The first one, which I'm aware of, is the Red Pill by Joanna Rutkowska. It's amazing. It's really efficient. I think it's efficient till these days. She seeks for a specific, it's not a string, it's like specific bytes in the memory, which are in constant look. It's like amazing. I think it's harder to find this kind of stuff than writing an APT in like some kind of way. There are many other things like timing attacks, calling the RDTSC, and trying to measure time stamp differences which are different between real machines and machines with hypervisor. You can do abuse for all sorts of hardware features. You can also call the CPU ID instruction and find like the ID that the maker of the CPU, which is different, and there are tons of stuff, tons and tons and tons of stuff. But why bother? There's like story time now. Those guys are the copy kittens. They're an Iranian APT we unveiled about, I think it was over a couple of years ago. They attacked the Israeli Ministry of Foreign Affairs successfully, if I might say. They took an open source project called Fish, the paranoid fish. Is anyone aware of Fish? Do you know Fish? Yeah, that guy in the back knows Fish. So Fish is a really good open source project, quite basic but quite good, which assists you to find out if your sandbox is hidden or not. You execute it inside your sandbox, and then you can see if it's detectable by malware, by simple techniques. So yeah, it uses the red pill, not the red pill, but other like the timing attacks and the hardware features. It uses all this kind of stuff, but well, it also seeks for files and registry keys and artifacts, and for dynamic artifacts we talked about. And then the logical operation of OR is performed between all of those different tests. And like in real case, like the copy kittens did, because they copycatted a fish. And then if you successfully triggered one of the tests by the original fish to be true, which means it is a sandbox, they won't execute their APT. So if I'm trying to evade to vaccinate against even like APT class Iranian malware writers, I can just create the file C program files VMware. It's as simple as that. Well, now it's time for a good idea, bad idea. Yeah, I hope that you all seen Animaniacs as kid. They're awesome. So, good idea. As a blue teamer, right? Not as a red teamer, but it's quite the same. A good idea as a defender is as the other way around, as a red teamer, but it's also the same as a blue teamer. A good idea is to search after persistent artifacts not to do all of this kind of problematic timing attacks, which, yeah, I know I actually executed some of those attacks on my virtual machines and it failed. I want to have a test which always succeeds in making me avoid being detected, because if I'm detected only once, my entire operation is gone in some cases. If I'm an APT group, you don't want to be detected when you're writing an APT. You will, but you try to postpone it as much as possible. You'll look for the common artifacts in most times because they won't be changed like every version or two. And well, it's also good for us when we vaccinate the endpoint. Bad ideas are also the same for both attackers and defenders, because bad ideas is going for trying to detect a specific process. But if you're starting before the other process, then you won't detect it because I don't know, it starts like 1 minute after the machine starts and you're already persistent. So you won't see it started. Your like test for the presence of specific AV will return false, although it is installed. And I can think about tons of scenarios like this. Other case you don't want to do this kind of test is human behavior. Monitoring, for example, moving a mouse. Um, well, yeah, that's like kind of a thing that I demonstrated. I wrote a tool called the Smooth Criminal, which detects sandboxes by moving mouses. Um, it's a really bad idea. All I did was, you know, what we do today in sandboxes is just like jumping the mouse from one place to another. And by that, we fool malware to think there's a real analyst moving the mouse. And what I did as an attacker, I just like did calculus, basic calculus, and I calculated the derivative of the location of the mouse, which is like, so and it's the speed of the mouse. And I checked if it's like, if it has low values, it's good. If it has high values, the mouse is jumping from one place to another, and I was able to define a threshold. But then, I just it's a really short script. It's a bad idea because I was able to push. I opened a pull request for a cuckoo, which wasn't purged yet, but I pushed the cuckoo a fix exactly for it. It is very easy to mitigate it. It's not robust at all, and as an attacker, you don't want to do this kind of stuff. So yeah, we kind of already talked about defenders, and I wanted to have like a good time. So let's do a bit of demo time. So I will open this one. I have a machine just for it. We'll see some examples of executing my script, which is available online. You can also this slide. No. Let's. If you want it, it's available on this like address, and I'll revisit the snapshot because I forgot to do it before the talk. Shame on me. Revisit the snapshot. Let's drag it over this direction, this direction, that direction, that direction. Yeah. So this is my VMware machine. I don't have VMware tools installed, so it's quite stealth, but it's not perfect. I will execute the fish, show you how much it's a very like stealth. You can do the same back home. If you have a sandbox, I really recommend using the fish. It's also open source, so no worries about it. If there's a test which is okay, which means I'm stealth, it's in green, and what's not stealth is in red. So you'll be able to see that most of it is in green. We're kind of good. Let's execute some malware to show how catastrophic situation is. Um, ah. No, no, yeah. Let's go, for example, for the Loki I talk about. This one. I have a proc one, which is filtered on it. And I use the magnifying glass because I don't have a telescope. Magnifier, yeah, that's good. And let's go down here. Okay, so yeah, you can see that it searches if, oh, I need to use the mouse. Do you see it on the top there, like the magnified one? You see that it searches if either ESET or Avast is installed, and once name is not found, yeah, can you see it up there? Yeah, okay, just make sure. It just like continues its execution, sorry, and it loads all the suspicious DLLs and, well, the things which are more suspicious for AVs, I guess, when it is loaded. And the CNC server is already offline, so it won't encrypt, but, well, you get the idea. By simply creating those couple of registry keys, you can avoid really nasty ransomware. Let's try another one. I have another case here of a malware called IronGate. It was unveiled by FireEye. Are there any FireEye guys in the crowd today? No. So it's also really, really simple. It's the thing that you will do as like a guy who don't know what you're doing the first day when you're bossing. You'll write a malware that evades VMware. In this case, it was written in Python. I used the decompile with a Y because it was compiled. But you can see the actual source with the comments, which is nuts. But you can see that the first function is detect VMware. And, well, what is this detect VMware? Well, what? I go to, yeah, V, and, well, it's the most, like, as I said, you don't want to be over complexing things when you write, and yeah, it's stuck right now. Awesome. Yeah, not stuck. Great. You don't want to make things like over complex when you're writing a malware. You want to evade virtual machines. They just like they have a commented test here for the SCSI port, which is a really good way to find a virtual machine. They commented it out for some reason. I don't know why. And they have another test here for the registry key of VMware, which is like the most obvious thing to detect VMware by. I have all the hashes of those samples in the repository. I see that I don't have time to execute all of them, but you can see that it just like searches for the most obvious things, like VM mouse or something. And let's do a quick revert snapshot. I will vaccinate the machine, and afterwards we'll execute the same sample, and will take only a minute. And you'll be able to see how you can avoid infections live in a demo, because it's a live demo. And we're good to go. Okay, so first thing, I will execute my script. Over here, it can get a flag. If you want, you can create only the static artifacts. If you want, you can create only the dynamic artifacts. I create both of them in this demo. You can see that like 10 processes will be created here in a second. Yeah, it's all the same executable, duplicated over and over again and renamed. But it works, so who cares? And let's execute. Let's start procmon. Execute the same sample. And we'll be able to see the difference. Start the magnifying glass. Yeah, you can see down there the red thing. That's Loki being terminated. It already terminated because we saw those registry keys. We'll see it now in Procmon. Yeah. So you can see that once up there in the magnifying glass, once it found that ESET keys was created, it's just like the next thing is a thread exit. It unloads a bunch of stuff and process exit, which is a win for us because our theory is safe. Yeah, there are tons of more examples in my repository, and there are tons of more examples out there. I see that I don't have time for questions, right? No. Yeah. Okay, so anyway, I'll be more than glad to take questions also afterwards. But if you have any questions right now, I prepared even a slide for it. So third slide. Yeah, that's the second cat of the day and the last one. Questions? Actually, there's a good example of infection marker that is created between malware, but it's not the malware which shares it. They use a framework to obfuscate the code, which uses an infection marker. So they all use the same framework, and by that they use the same infection marker. Yeah, yeah. And Spora, for example, you have a really long-living family of ransomware which was really effective, and they all use the same UTEX because why not? I'm lazy also. I understand them. I did an entire talk about copy pasting other guys' codes and writing malware from it. So I'm the same. So thank you. I'm available for more questions afterwards if you want to.